From Chicago, welcome to 3Degrees Discussions. I'm your host, Mike Vasquez. This is a podcast devoted to the stories behind the innovators, entrepreneurs, and leaders in the 3D printing industry.
We had this initial laser powder bed was just all it and a bit, and it really dominated the market if you looked at machine sales and everything. Whereas what we're seeing over the last couple of years is actually that's shifting a bit, and the pie's growing, but also the slices of the pie are changing, and we're getting a lot more what you'd call non-conventional 3D printing types of techniques emerging, and the reason that they're emerging and really starting to take market share is because they're lower cost.
That was Alex Kingsbury. Alex's career in additive manufacturing spans both industry and R&D, specializing in bringing new technologies to market. She has successfully co-created solutions and partnerships in the sectors of aerospace, defense, biomedical, and resources. Alex is currently an Additive Manufacturing Industry Fellow at RMIT University in Australia, and there she works to enhance links between industry and the university. These links extend across research and teaching and learning functions at the university. Prior to this role, she worked as a consultant to industry, specializing in metal additive manufacturing. Alex holds a Bachelor of Engineering degree with a major in metals processing and is currently a PhD candidate at RMIT. Well, Alex, thanks for joining me on the podcast today. Why don't we just get started with telling us what are you up to right now?
Oh, thanks, Mike, for having me on. So what am I up to now? I am working at RMIT University. I'm an industry fellow there for additive manufacturing. So an industry fellow role is a little bit unique, and there are a couple of sort of fellow roles around, but they tend to be pretty curated. And certainly at RMIT, what it means is that you're someone who's had a lot of experience in industry and can bring those connections and knowledge into the university setting. And it means that you can essentially be an academic without having a PhD. I've had a long-standing relationship with RMIT. I actually went there as a student, so in a lot of ways it's like kind of coming back home. But as it so happens, I'm also working on a PhD as well. So I figured, if I'm going to be in the university setting, well, there's ready supervisors there, happy to help me, all the equipment I need. So it's a great opportunity to pursue a PhD. It's always been something that's been, I guess, on my mind as to whether or not I would do it. And it's always been a question that's come up at various points in time in my career, because I've always been a little bit on that sort of research and commercial interface. So yeah, now's the opportunity to do it. And I kind of knew that when I had the opportunity at RMIT, it was either it's now or never. So that's what I'm doing now, as well as my job at RMIT.
And what's it like specifically with the additive space and getting engagement from companies? Do you see, because it's additive manufacturing, kind of this newish technology for a lot of organizations, that it's kind of easier to draw companies in, or is it still quite challenging to kind of get people to be excited about the technology when it's in some cases still fairly unproven?
So I don't find it's hard to get people excited about AM. I think just being able to show people the machines, being able to look at lasers, and especially being able to showcase some of the things that we've made and the projects that we've done. The excitement's never far away from any of those stories. But I think that when it comes to people actually putting their money where their mouth is and being willing to lay down their cash to invest in the technology and getting them to really seriously consider adopting the technology, that's absolutely a big challenge. And I guess the setting in Australia is such that, manufacturing's been quite a strong set for us in the past, but it has been quite dominated by major global companies, and particularly in automotive. So, we had a really strong automotive manufacturing presence here in Australia for a very long time. And that was really driven by a lot of economic policies that were put in place quite a while ago, and had been ramped up. And they were all around sort of protectionism of the industry. And unfortunately, what that meant is that it was, and so that those protectionism measures were really ramped up a lot over time. So where we got to in the 70s, they were the highest, I think, in the OECD. So in the 80s and 90s, we had a real unwinding of those protectionism policies, to the point now where we don't do mass auto manufacturing in Australia anymore. So that's been a really, really big shift, and I think a big shift in our psyche as well, because there has been a bit of a sentiment that's really pervaded around manufacturing is dead in Australia. And there's been a lot of really hard work being done to try and reverse that feeling, because it's certainly not dead, it's just transforming. And the exciting part in that story is that there is a real opportunity here. And, you know, like there is in every other advanced economy in the world, where a lot of that mass manufacturing has gone to those lower labour cost economies, and we're a high labour cost country, and so it gets pretty hard to justify a low value product. But we have definitely a value in high value product, where we can make that work for us, and I think it really relies on advanced technologies, and it relies on having some really good and deep IP as well. And the advantage of the whole automotive experiment, I suppose you could call it, is that we were able to develop a really great capability in Australia. So we have some amazing product designers here, for example, and in fact Ford has still maintained a design and research centre here in Australia as a result of that. So it's not all bad news, definitely. But I suppose getting to your question, which is, adoption, what we have in Australia for manufacturing now is that we have a lot of SMEs, and a lot of them are family-owned businesses. And to convince them to make the jump into additive is actually pretty difficult. There are a lot of barriers in place, not least of which is money and finances and cost. This is not a low-cost technology, and it's not a low investment type technology, AM. So I've done a lot of work with local industry here, and I have to say, I think like the biggest hope I have for adoption of additive is actually in the startup space. So and that's really what we, in the earlier days of my work in additive, I was working a lot on trying to push the technology out into our existing manufacturing industry. And I found that there really wasn't a lot of appetite for it. There wasn't an appetite for risk, and there wasn't an appetite for higher capital investment. And where we got the most traction was in that startup community and like applied tech, deep tech, applied tech startups, and they're the ones that are really willing to really push into new frontiers of manufacturing.
Yeah, one of the things that I've observed in the US, I mean, similar with the small, medium-sized organizations and manufacturing outfits, is they're not opposed to adopting new technology. It's one of the things where they don't see a demand for the product. So if they're manufacturing in automotive already or in medical implants, that's changing a little bit. But like if they were to buy a $1 million EOS or SLM or Renishaw system, they don't know if they can fill it with jobs or contracts. And by the time you get qualified, I mean, that's 2 or 3 years out. And so leave you hanging with a kind of $100 or $1 million piece of equipment for 18 months is not always that appetizing. Is it similar in Australia, where you have there's a somewhat lack of pull in terms of what can you actually 3D print?
And also, I think if you are looking at really pushing into particularly new product spaces and new markets, like that requires a lot of work on the behalf of a business. They've really got to go out and develop networks, really do proper market assessments, and do their due diligence. And that's just time alone that takes an enormous investment, and that's before you've even decided to outlay the big capital, outlay the money, not just for the machine, but also for the facility, and also for the working capital as well. And then you've got costs of software, and then you've got training for your staff. And then, as you say, you've got about probably 2 years until you're really realistically getting product out into, certified, qualified product out. So that's an enormous amount of investment, and it's a big ask, particularly of a small business. And I think that I have seen examples of where small businesses have done it, and it has been a significant investment for them. It is paying off, and that's been really great to see. But there's not too many, and it's so unfortunate. But there's this saying in Australia, and it's like the 3Bs. So once you get the 3B, and so Australians have got a very a bit of a laid back kind of reputation, and I would say Australians are very, very hardworking, but there is definitely a thing of, once you've made it to a certain point, then you can relax. And if you are a business and you've gotten your 3Bs, so I'll tell you what the 3Bs are. They are boat, beach house, and BMW. So once a business owner kind of gets to that point in their life, the appetite for risk is very low. They are not willing to put years and lots of money into investing in something new that may or may not pay off. So yeah, it speaks a little bit to the mentality.
Yeah. And is the government supporting these efforts as well through kind of university collaborations or other initiatives?
Absolutely. Yeah. So we definitely have a very very supportive and encouraging government, and even more so now, sort of since COVID, than ever before. We've probably government in Australia is sort of federal and then state level. We've seen a lot more support happening at the state level, but now we're actually starting to get some real traction at the federal level, which is pretty important, because this is what's informing all of our policies around manufacturing. And this is something I've been pushing for, is while we might have really good state leadership around manufacturing, we actually really need a cohesive federal national plan around manufacturing. And there is a couple of things that I've sort of really pushed for the government to do. And it looks like, fingers crossed, like they're actually starting to really take notice. And so COVID's been fascinating from that point of view, because we're an island nation. We are separated by great distances from our major trading partners, and it's highlighted our supply chain insecurities, I suppose, or instabilities, and what we might need to do to look to safeguard those. So I'm not about saying we should bring back protectionist policies around manufacturing, but I am definitely about saying, we need to actually map out our critical supply chains and ensure that we have, we can make what we need when we need it, and we don't, if we can't rely on our major trading partners to supply that. And I think that, if I can comment, I guess, in more general terms around the state of the world, I think we are heading into a bit more of a vulnerable, volatile period of time in history. And, and something like a pandemic, which is, totally sort of a cause of nature, I guess. But this is really highlighting the ways in which countries need to look after their own interests.
Sure. And on the flip side of that, kind of what's the workforce like in kind of Australia, both on the small, medium-sized manufacturers that you've work with to bring into the university system, and even large manufacturers, but also on the flip side of kind of students coming up in STEM or related fields, is manufacturing an attractive career path?
Yeah, so I guess one of the things, and this relates a little bit back to your last question, we have a very, very strong university tertiary education sector here in Australia, and that's been able to be cultivated, I suppose, because we have a lot of international students that come to our universities, and so education is actually our second biggest export. And what that means is that we have a lot of international students coming into our universities, and with them bring some good funding actually, and also some competitiveness between the universities, because you're not just competing for local students that happen to live in your area, you're also competing on a global scale for the international students as well. So the universities have really sort of beefed up in terms of their capabilities and their offerings, and going. Sorry, I'm flipping between your two questions, but going back to your last question, because you were asking about government support for collaboration. A lot of these, there's a lot of support for university and commercial interests becoming more aligned. And so there is pretty much every grant program out there is, for projects, involves some sort of university business cooperation. And that's where someone, in my type of a role becomes quite important, because it's being able to facilitate those connections between business and university. Not that, RMIT actually does a spectacular job, without people like me anyway. They're doing just fine. But it's all about that move towards, really pushing universities outside of the lab and into businesses and cooperating a lot more, because that's certainly the direction. But you asked about the workforce, and I think that, like I said earlier, we did have a bit of a national psyche around manufacturing instead. RMIT actually still runs a Bachelor of Manufacturing. We're one of the few universities that do though, and certainly the students in that program are very enthusiastic. But I suspect they're probably from families that have had manufacturing backgrounds or been involved or around and in circles with manufacturing communities. So they're probably a little bit more aware and attuned to the potential of manufacturing, I think. And in general, the workforce, as a result of these very large research, institutes and also universities, the workforce is very well educated. And that's, that goes hand in hand too with our high labour cost as well. I think that, as we were just sort of mentioning earlier before we started recording, there's a real lack though of, hands-on technicians. And I think that there's that really great gap of people that have those skill sets, where you don't need a degree, and you certainly don't need a PhD to be really useful on a machine. And there's been a lot of work and effort put into by a certain industry association I'm thinking of, into creating a cohort of workers that are highly skilled, but weren't necessarily looking to go down a university career path, or a qualification path, and that's a bit of a gap for us. And I think that's a bit of a gap though for many countries around the world, particularly where there's highly educated workforces, because you can sort of polarize the workforce a bit.
Right, we certainly see that here, no doubt. And kind of flipping the switch a little bit, tell me more about what you're working on for your research for your PhD.
I'm looking at wire arc additive manufacturing. So for high performance alloys, okay. Aluminium alloys particularly. So when I was considering what to do my PhD topic in, I was thinking about, what interests me and what sort of gets me excited. And to be honest, like all of additive does. So it was quite hard actually to to really pin down what it is I wanted to do. And what I did think was that I've always been, like I said, on that sort of research commercial interface. And so one thing I knew was that what I wanted to do was a PhD that had some sort of applicability or sort of near translation to the commercial world. And so that was like my primary driving force behind topic identification. And the other thing I was sort of thinking around at that time was, I started out my earliest sort of I guess familiarity with additive was with electron beam powder bed, and then not long after that we invested in a laser powder bed, and then and we'd always when I was at CSIRO we'd always been working in cold spray. So cold spray is like, I could talk about that for a whole nother podcast, but I'll leave it. But we were taking cold spray from a coating technology into an additive technology, and so I'd had this great experience of working across all different types of modalities of AM, and what I was seeing, and because I'd been a bit working on, quite a lot working on the costing models and the business models around additive technologies, is I was seeing, it becomes so hard to justify business models around a lot of these technologies actually, and knowing that it's going to be the cheapest technology that has the easiest in, essentially. And we saw, and I think you've been around long enough, Mike, to have seen the progression of additive and in the metal space and how things have worked. And we had this initial, like, laser powder bed was just all it and a bit, and it really dominated the market if you looked at machine sales and everything. Whereas what we're seeing over the last couple of years is actually that's shifting a bit. And the pie's growing, but also the slices of the pie are changing, and we're getting a lot more what you'd call, like, I guess non-conventional 3D printing types of techniques emerging, and the reason that they're emerging and really starting to take market share is because they're lower cost primarily. And so anyway, that's a long way of saying what I wanted to do was something that was near-term, near the commercial need, but also was one of those sort of emerging fields that was that was on the lower cost end. And so that's where WireArc comes into that. WireArc's fantastic because it's got, it's based on welding technology, which is kind of pretty simple in a lot of ways. And there's decades and decades and decades worth of knowledge, of welding knowledge and experience that you can translate into WireArc. WireArc definitely has its own unique challenges that are unlike welding, but there's that wealth of knowledge and experience that you're going to be bringing into this technology, which, when you talk about laser powder beds, you really didn't have that. And even powder metallurgy itself was still a sort of not a very well-known field, whereas welding, like, you could have a welder in your backyard if you want to, and do home projects, and so it's just a lot more well developed. And WireArc also uses wire as a feedstock, and it's sort of funny because, like, all of my early experience was all in titanium and titanium powder. And so it would have been a really natural fit for me to have gone on and done that as a PhD topic. But I've ended up doing aluminium and aluminium wire. And anyway, but the wire is, again, you have, it's like a commodity product, right? So you have all of these really established supply chains around welding wire, certified alloys that you can use, just translate it straight into WireArc. Whereas AM laser, powder bed technologies are much more tricky in that respect. So I really liked the fact that, I felt WireArc definitely has a lot of very untapped commercial potential, and we're definitely seeing that, now, last year, these companies starting to spring up, but like having a traction with industry, like laser powder bed, I don't think really had.
And what do you think are the top applications for that technology?
So WireArc works really well where you have anything thin walled, and it's the whole sort of buy to fly scenario argument. And with that, it becomes, if you're talking buy to fly, then you're talking high value materials as well, which funnily enough is not what I'm looking at. I mean, aluminium is not that high value, but that is really a lot of where the value proposition comes in. And then also lead sensitive items as well. So if you look at defense and aerospace, any sort of ribbed type of product where, which is large scale, and you need to have big, expensive machining centers to do that work, and you're machining for a really long time. And that, machining is cheap, but if you're doing it for long enough, the cost really adds up very quickly. And when you're doing it with a high value material, it becomes much less economic to do it that way, and much more feasible to do it with wire arc. And in terms of, aerospace defense is a really big user, but actually, funnily enough, we're seeing a lot of interest on the marine side of things. So that's been quite popular. And I think, a lot of aluminium alloys that are used in marine already, they're weldable, they're whammable, and products can just be made pretty easily. And marine's not actually a really high value market either. And also it is a bit lead time sensitive. So, you'll have a ship come into dock, and it's got a certain period of time for maintenance, and then it's back out again. Not dissimilar to defense actually. And I think a really exciting and emerging area is space as well. I think we've seen relativity space just this week, I think it was, made a huge announcement about their recent funding round, and and so I think there's a lot more on the space side of things that can be done and looked at.
Yeah. And I really can relate to your pursuit of a PhD that has relevance. I mean, that was one of the draws that made me jump from kind of where I was doing some of my other work to Loughborough, and getting, I ended up being on a project that I was directly working at a company, Burton Snowboards, during kind of a third of my PhD. So developing materials specifically that would eventually go on snow. I had to test them, which was a tough part of the PhD on the mountains in the winter time. But I mean, it's that relevance that you get to glean from, what are the real problems in industry? What are the, it's not always about the technical solution that's going to solve something. It's knowing the right kind of angle to sell it, or the angle to pitch it up the value chain, and what do you actually have to prove? Is it not mechanical properties? Is it appearance and speed? And I think that grounding was certainly very beneficial for me to get during that time, and hearing the voice of the customer in some aspects. So I think that's It's so lucky to have that experience of working with a customer during your PhD, and being able to get that sort of real-time feedback, because often the work is done almost in isolation, and it's not until afterwards when the papers are published and the work's done, and it's oh, okay, we wish you'd actually looked at that instead, but that really comes from my background at CSIRO. So my first job there was in doing those commercialization studies, and it was what I thought was so interesting and valuable about the work that I was doing was being able to look at something on a lab scale, and then scaling it up to a commercial scale. So doing all of the concept design around that, but then also doing the costing, and then after the costing, going in doing the market analysis and saying, okay, where does this fit in a market, and how can we justify it, basically. And the best part of it was being able to feed back new research directions into the project. And it might even be something simple, for example, there was one project where they were using a lot of argon, and they said, oh, when it gets to commercial scale, it's fine that we're using a lot of argon because we'll just recycle it. That's no problems. That's what they do at commercial scale. But it's well, actually,
you don't know that because they don't do this at commercial scale just yet. And if we do the figures on recycling it, it actually makes it quite expensive. It makes it quite expensive from a capital point of view, which for any business that's looking to invest, capital is it's the thing that eats into your your hockey stick curve, your return on investment. It goes right down in those first couple of years, and that's really not what you want to see out of a project. You want to try and minimize the upfront capital, and get some revenue pretty quickly. And so how that was able to inform the research direction then of that project was like, well, actually, argon's really important. We've all been ignoring it all this time, trying to get the product purity up. But let's be really mindful of our argon use and try and look at ways that which we can minimize that, and then feed that then into our commercial model to really dramatically bring down the price or the cost of our product, right? So you can make some really good research decisions when you're able to apply some commercial sensibilities. I mean, this is very much industrial research, right? And like, having given my little soapbox rant, I absolutely believe that there is room for fundamental research, because that is, what we're going to be doing in 20 years' time. But for me, as you can probably tell, the passion really is in the industrial research.
And so what sorts of advice do you give to people kind of coming up the ranks, either in the university system or just generally interested in the additive space, to get their start?
So, one thing I find is really interesting is like, if you look at people who are in additive and then you look at their career progression and sort of what they've done and how they've gotten into 3D printing. Because, I know for me, I feel almost like, how can I give advice on getting into 3D printing? Because I found it completely by accident, as probably most people have.
So far on this podcast, I think I've done 21 interviews, and I think almost 20 or out of 21 have found that to be the case.
Yeah. So I'm not really sure I have the recipe for success in getting into additive. I was just speaking with Janet Carr from Link 3D yesterday, and she and I are involved in Women in 3D Printing, and one of the things she's doing there's a whole lot of work that they're doing with youth women in 3D printing, and one of the things that they're doing is profiling women in 3D printing and then asking them a couple of questions. But down the bottom, Janet's got a little career progression, and I thought that I made the comment to her. I said that is such a great idea, because the thing is that it's not like I could say to someone, "Oh, just do what I did," because what I did was very unique and also very time dependent, and also very much like it's not like I was really seeking it out. But I think that if as a young person you can look at lots of different people in the industry and see all of the different ways in which they've found 3D printing, then that gives almost like a macro view of what a career in additive looks like. So yeah, I think that's a really kind of cool way to do it, and I love the work that women in 3D printing do, from that point of view. But in general, I mean, I have, as part of my job, I do supervise students. I supervise master's students and final year students, usually for their it's their final year thesis, and so they're just finishing up when they're with me, and it's always really it's always really fun to be there for them as they're just finishing uni and about to launch into the job market. But honestly, some of the best advice has been not 3D printing specific at all, and it's just been and like a bit cliche, but like, be true to yourself and be true to your passions and your interests. And one thing I think a lot of people feel pressured to do is have a plan for where they're going to go and what they want to do. And I don't think that's actually important. I think what's more important is that that people follow where their interests lie. And I think if you can constantly be engaged in what it is that you're doing every day, then, you know, the rest will work itself out. And that's absolutely how I got involved in 3D printing, has been very much like, this is interesting, and I'm curious about this, and I want to learn more. And for me, it's been a field, and I'm sure it's been the same for you, Mike, like that you just continually learning new things. You know, there's always the opportunity to learn new things, and you're working in an emerging technology. There's always new developments, and it never gets old. So yeah, very exciting from that point of view.
Sure. And so as we wrap up, what are you excited about for 2021?
Getting out of my house. Actually getting out of my house and getting into the lab. So I started this PhD mid-year this year, which, you know, started a PhD in the middle of a pandemic. But there was some strategy behind that, because I was like, you know, I'm at home and I can't be in the lab, but this is a great time to do a literature review.
Right.
So that's been what I've been doing so far. But I'm definitely kind of itching to get into the lab, and there's a business in Australia that uses WireArc, and so but they're in another state. So I'm really keen to go and visit them, and to, you know, really get the sort of hands-on experience that I really think I need in order to be a good experimentalist for this PhD. So I'm excited about that. I really honestly haven't looked too much further. I would love to be able to get on a plane and travel. And there's one thing that I think this whole year has highlighted. I mean, I think for everyone, but I feel this very keenly because I am so far away geographically from a lot of the people in the industry, a lot of businesses, a lot of colleagues even, and you know, and a lot of good friends as well. So I'm just really itching to be able to get on a plane and go and you know, see everyone. Hopefully, maybe even be at Form next November, which would be really great. But yeah, so there's some tentative plans of travel next year, but it's all still a little bit up in the air.
Awesome. Well, thank you so much for joining the show, and we'll hopefully see you at Form next year.
Hopefully. Okay. Thank you.
All right.